Oh, hello there. Welcome back to the shed. Some good things going on. Got my first channel sticker from one of my subscribers, Jim's Workshop. And he has a really excellent channel, and I really think if you haven't seen it, you should go and check him out. He has some really excellent footage on his machines and on some engines. So go and take a look at that. I do have a couple other channel stickers up there, Mr. Crispin and Joe Pye, but I did have to buy those ones. Well, Mr. Crispin gave me his for free, other than a small shipping charge, manufacturing charge, setup charge, tooling charge, and manufacturing charge. So apart from that, it was completely free. So very good value, I thought. And his mugs are excellent for drinking tea from. I recommend them. Anyway, moving on, in today's video, I'm going to add some 256 tapped holes around the cylinder of the number 4 steam engine. If you look at the assembly drawing, you'll see that there is a piece of brass sheet which has to be cut to size, have holes put in it, and then wrapped around the cylinder. And in order to attach it to the cylinder, there needs to be a series of holes along each edge and corresponding holes in the cylinder to match. Now, it's entirely possible to drill and tap those by hand very successfully. I'm sure that's been done. But I really wanted to make sure that the screw holes are perpendicular to the surfaces that they go into, just to and to make sure they're accurately positioned. So in the end, I decided what I would do would be to map out where the holes go and use a combination of the linear slides on the mill and a rotary table to index the part around and to move the part backwards and forwards to get the holes accurately positioned. So that's what today's video about, and it will include a little bit of explanation, as best as I can do it, as to how to read the vernier scale on a rotary table. It took me a little bit to figure it out, actually, and in doing that, I didn't find a whole lot of explanation on that on YouTube, which was surprising. Now, I know that Joe Pye has a segment somewhere on that, but I actually didn't find it readily. So if I can find that, I will link it in the description below. But hopefully this video is somewhat interesting and a bit informative as well. Anyway, there you go. So as always, hope you enjoy it. Thanks very much for tuning in, and see you later. So I use SolidWorks to make a model of the sheet metal, and the advantage to this is I can plot out where the holes need to go so that I can get those spaced reasonably well. And then this will also include the stretch out that happens when you form a piece of sheet metal. So from this model, I was able to generate a drawing which I can plot the flat pattern out one to one, and then cut that out and use that to lay out the sheet metal. And what I plan to do is cut that out, use a piece of aluminium, thicker aluminium, to hold the brass sheet down so that I can drill these holes. I will dimension this, but then this will be a nice reference as I lay everything out and drill it. The other thing is that I now have angles and coordinates for all the holes, and those are what I will use to plan and drill and tap the actual cylinder. So I will have this drawing on hand when I get to that point. Could have figured that all out by hand, but it's a lot more interesting to actually model the thing and then plot it out. Anyway, that's what's going on. So we'll get on with it. Here's the life-size flat pattern layout, which I can verify is 1:1. Near as damn it, should be good enough for this anyway. Look at that. A smidge under 10.75. A smidge under. Good enough for me. Here's the setup. So I've got the rotary table set up, and that's square to the y-axis on the machine. What I've done is turned up 2 aluminium fixtures, and both of these have a shoulder that is accurately sized to the bore. This one has a shoulder that is sized to locate it centrally in the rotary table. This is actually a taper. This is not a taper, this is just sized so that it is a very close fit with wherever it touches on the bore of that taper. So that holds that central. And then this has a step on it to locate in the bore of the cylinder as well. The idea is that once this is clamped tight with a long bolt, I can position the center of this bore horizontally relative to the position of that bore and keep the rotary table on 0, and that way I can move this around so that I can drill perpendicular holes around these faces and then rotate it around to get these faces level, and then rotate it around to get this position vertical, and I can gradually drill and tap holes all the way around the part. Having the tight locations on these just makes it very easy to get this centered. So, all right, I'm going to get this all clamped up. So I'm going to try the paper template now. Just kind of do a very approximate test fit. Bearing in mind the stretch out won't be exactly the same. Oh, that's good though. So I've got the cylinder set up now. It's clamped securely between the 2 spaces. And so what I've done is measured the outside diameter of this boss, which was turned at the same time as the locating step, so those are concentric. And then I have a gauge pin, a close fitting gauge pin in the valve bore here. I know that these centers are 2 inches apart from when I made the cylinder. So what I do is find the crown of this boss, and then I zero that in the Y, and zero the Z axis, and then come over and touch off, find the crown of this, and that confirms the Y measurement, and then I can measure the Z height change. So the calculation is this diameter minus this diameter divided by 2, and that gives the drop down, and I used that to rotate the part and get the center lines on the same plane. So let's just check that. So come down here, bring the test indicator to 0, and as I go backwards and forwards, you can see that that is the crowning point. Come across. come across 2 inches. Down. .676. The number I'm looking for is 0.6757, so 3/10, honestly, plenty good. Let's just go backwards and forwards here. Yeah, and so you can see that the crown of that pin is right on the 0 there. So now I know that the bore of the valve is horizontal relative to the center line of the cylinder. So now that I have that leveled up and I have this on 0, I can begin moving the part around and drilling the tapping holes ready for tapping. I know the length of the part, that's been accurately measured, so I can touch off on this face in order to get my position in the x-axis and come across to the appropriate position this side as well. So I will get the drill chuck and everything set up and we'll proceed. Let's have a look and see if we can understand how to read the vernier scale on this rotary table. Rotary tables are all set up in a similar way. The exact ratios and things can change, but the principle is still the same. So around the table is 1 degree increments. On this particular rotary table, 1 complete turn of the hand wheel is 4 degrees. And then there is a 20-second scale, vernier scale, for the fine measurement. So let's have a quick look. Right now I'm at 160 degrees here. I'm looking for 158 degrees, 14 minutes, 24 seconds. That's the number that's required in order to get this surface horizontal. So we're at 160 degrees. Back this out and let's have a look at the hand wheel. So you can see here there's 0 on the hand wheel, lines up with the 0. So this is exactly on 160 degrees. Now I have to back it off. So that's 30 minutes. And that's 1 degree. Now going this direction, I'm incrementing the rotary table, so I've actually gone to 161 degrees. I actually want to go the other way. I just went this way as a demonstration. So let's go back. Now I'm going to take the backlash out. This is the way I've been going. So there we are, 160 degrees. Now again, that's 30 seconds, so that's now 159 degrees, 30 minutes rather. Another 30 minutes takes us here. So that's a whole degree. So we're now at 159 degrees. Another 30 minutes. So we're now at 158 degrees, 30 minutes. This is a 2-minute scale. So lining this up with this, I'm now at 158 degrees, 20 minutes. 18 minutes, 16 minutes. This is the 14-minute point. If I keep going, we now have this line has lined up with the 60-second mark. And as you can see, the 0 on the fixed scale is about halfway between 14 and 16. So I'm now at 158 degrees, 15 minutes. Now I go a little bit more. Now this line is lined up with the 20-second mark, and that's going to be as good as I can get it. So I'm now at 158 degrees, 14 minutes, 20 seconds. And the resolution on this particular rotary table isn't that great on these lines. But it was a very inexpensive rotary table. So for the most part, that's worked out pretty well. If we look at the drawing, which I've marked up because as usual, the dimensions I put on the drawing aren't what I actually need to make the part, but I'm now at this location. So I came all the way around, center drilled all these positions, and then rotated around to the 158 degree, 14 minute, 20 second mark, which gets me right to there. Now what I have to do is move the y-axis 0.429 to get the next drill point. So I'll set up and do that. And then return this to the 0 mark because we should now be right in line. But we are clearly not. So I must do some investigation and figuring out. I've got something wrong. Okay, back soon. Okay, take a look at this. At the end of, as I was going around drilling these, and I got to making the center drill mark for this position, I realized I was way off. And you can see that here. It's very clearly not over the center where it should be. And I realized that I have very sensibly not actually found center position of the cylinder. Established that this center relative to this center, and I got that, checked that the centers were the correct dimension apart, but didn't actually establish this center. So I have to do that now. 2 ways of doing it. I can use this part, which has been machined to have an OD concentric to the ID step, or I could go and find this center with a gauge pin and then move over. But the simple thing to do is just use that. So anyway, I'm going to get this centered up, reset my 0 positions, and then go round and center drill the various locations again. So downside is that I've got a couple of marks around the perimeter here that are in the wrong place, but those will be behind the lagging, so I'm not going to stress too much about that. The key is that the actual tapped drill holes will be in the right place. So I'm going to get set up now. Edge finder in position, and away we go. Made a revised drawing which has all the data on it that I actually need for making this part. So I've got the absolute angle positions on here, so I can easily find those on the rotary table, and then the linear dimensions. And I'm actually frankly embarrassed to show you this. What an awful drawing. Look at this. Notes on top of dimensions, dimensions crossing over other dimensions. That's horrible. Oh well, I'll fix that later on, but at least this has the information I need. Okay, let's do it. All right, ready to go. I've tried to frame this up so that you can see what's happening with drilling, the position of the rotary table and the hand dial. So let's see how this goes. All right, that's all of the hole positions center drilled on this surface. Now I have to do the same over here. Arguably, it would have been better to go backwards and forwards. Doesn't really matter, I think. So what I'm going to do now is finish that one off, and then I'll get the tapping drill in place and shoot some video of drilling and tapping all of the holes. I had to install my ER11 collet chuck in order to get these ones. I didn't have quite enough room between the face of this and this part in order for the other chuck to work. But this is fine. This is a number 50 drill. No, it isn't. It's a number 49 drill. For a little more clearance for tapping into cast iron, or 256 threads. I've zeroed the drill point to the top here, and now I'm just going to repeat what I just did. I'm going to go around, drill the tapping holes, and then move over and drill the tapping holes, and then come back and drill the threads. So here we go. High 2, power on, and away. got my 256 tap in my Joe Pye style miniature tap holder, and all I'm going to do now is repeat the sequencing you just saw for drilling, using a tap guide to hold the tap vertical. Oh, I'm almost off camera there. But I'm not going to film this whole thing. I'm just going to do this. I think you get the idea on the use of the rotary table now. I am going to use the table to step around and use the mill to guide the tap, just to make sure I keep it straight and minimize the chance of any breakage. I think it's worth doing that. But no need to film that. So I'll be back in a little while with the completed part. So here's the finished part. As you can see, nicely spaced holes, accurately located, and that's what it was all about. You can also see where I went wrong. Oh dear. However, such is the way of things. Those features will remind me of the journey when I look back at them, but they will actually be covered by the brass steam jacket, so I'm not too concerned. What's more important is that the final result is exactly what I wanted. Managed to choose a hole spacing that missed all of these tapped holes. Was quite close in a couple of cases, but I was able to keep the pattern identical top to bottom, which will be good on the final appearance of the engine. So that's it for this part. It did occur to me while I was doing it that I could have actually machined the outside to an accurate profile, doing exactly what I was doing, creating the whole pattern. If I'd put an end mill in there, I could have rotated this around, moved across, rotated around, moved across and around, and dusted this off, but not super critical. I wouldn't normally drill and tap into rough cast surfaces, but by pecking at it with the center drill, it was pretty easy to make these locations. So anyway, happy with that. Thanks very much for watching. Hope you enjoyed that, and another step closer to completion. Next step will be to make the actual brass jacket to go around this, and then we'll be into painting, assembling and finishing. So hope you come back for that. In the meantime, all the very best, stay well, and see you again soon.